Welcome back to College Algebra here at HCU. Today we're going to be looking at section 2.4, or complex numbers. We're going to be looking at what happens when you get the square root of a negative number or an imaginary part of a complex number. And we're going to look at how some applications of that, and then we will look at some cool properties of complex numbers. So let's get started. So this whole idea of complex numbers comes from, and if you've heard of the quadratic formula or you've seen any square root or radical anywhere in the math world, you know that this bad thing happens, right? Like we said last week, this bad thing happens when you divide by 0. A second bad thing happens, or a second domain restriction happens when we have that negative number right there inside of a radical or a square root. And so to get around this, to keep working through the math world, while dealing with this really bad thing, because we don't have the square root of a negative number. No number times itself is going to end up equaling a negative number, because no number, any negative times any other negative, is going to end up equaling a positive, right? And that's kind of the fundamentals of where we get this thing. And so we've said, all right, well, let's define the square root of -1, which is the simplest negative square root we could think of, as this complex term I, as this imaginary number, I. And so, using that definition and using an I, we can go through the mathematics of tons of complex numbers, of pure imaginary numbers, of mixed imaginary numbers, or what we call a complex number that has a real part and an imaginary part. And then we can apply all of the math that we already have to complex numbers. So we're going to start off real quick by just looking at the simplest form and getting a little practice reducing radicals. And so we're going to look at this square root of -24, which has a ton of factors. If you remember factor trees, where you can break it down into like 4 and 6 and 2 and 2 and 3 and 2, and use those factors in that factor tree to solve for a simplified standard form of a complex number. So what we're going to do first is we're going to rewrite this using properties of exponents, properties of square roots, and say a square root is just the multiplication of the factors of that square root, which means in its simplest form, we can split this up into -1, which there's our definition, times 24. And then we can do the same thing with 24 a bunch of times, right? And I think the simplest way to get it down would be to look at the 4s, because the 4s are going to reduce, right? So if we break down that 24 into 4 and 6, one of those terms is really nice. And don't forget that we've still got that -1 underneath the square root sitting out front. So what we've done is we've just expanded this square root so it's a little easier to simplify for us. Sometimes you'll see some teachers circle that negative and bring it out front and put an I. That's just a little shorthand to show you, hey, I know that that negative can be taken out and turned into an I, but we see that same thing happening right here. And so now to reduce it, we're just going to turn that -1 with a square root into the I, the imaginary term from our definition at the top of the page. We're going to simplify the square root of 4, which you know is 2. Don't forget that these are multiplied by each other. And then the square root of 6 doesn't simplify because its factors are 3 and 2, and so we're going to leave it alone. And then just to pretty it up a little bit, we usually write the coefficient in front of the I, and we can leave it just like that. Most of the time you'll write the I in the front, just so that you avoid any confusion. So for instance, if we were going to write, don't do this, this is bad, don't do this. But if we were going to write 2 times root 6I, now we've got a little confusion as, wait, does that square root go over that I or not? And so you'll see it pretty much all the time standardly written with the I in front, so you know, no, that I is not under the square root. The I was the negative sign under the square root. And so we've got a standard form of a complex number. All right, I'm going to skip graphing. I'm going to go straight to adding. You can read through the section in the book to get all of the things that we skip over in these notes. For the time limit, we don't have the ability to go over every single triad in the book, but I highly encourage that you do. So let's look at this. I said try adding them as well. I'm going to leave you to do that on your own, but we're going to subtract. And it kind of works exactly how it would work with a variable like we did in the last section. And we're going to treat I like a variable, knowing in our brain what its actual definition is. Its actual definition being the square root of -1. So we're going to subtract. So I'm going to take 2 plus 5I, subtract, and don't forget to use parentheses to be really careful with what we're doing. Oh, it says from, not subtract by. So actually we're going 3 minus 4i, subtract 2 plus 5i. Easy mistake I made. Make sure you read the problem, subtract that from a number, not by a number. And we're just going to treat it in parts. So what is 3? Actually, let's distribute that negative sign. Practice the distributive property. 3 minus 4i minus 2 minus 5i equals, now we got 3. This is that combining like term step. So we did distribute, combine like terms, that DCMAM, don't call me after midnight. Distribute, combine like terms, move all the x's to one side, add or subtract the constants to the other, and then divide that last coefficient. Go back and watch section, the linear and rational function section for that info. So 3 minus 2 is 1. Negative 4i minus 5i is negative 9i. And we've got ourselves a complex number. With a real part, if you want to look at those definitions, we've got ourselves a real part, and we've got ourselves an imaginary part from the definition up above in the textbook and on these notes. All right, that's that. Try adding them. It works exactly like you would think it would. We're not going to change the I. We're going to leave the I alone. We're going to multiply because it's going to give us practice foiling, which we kind of assumed you knew in the last section. Might go over it a little more in depth here. If you know how to FOIL, that's awesome. Some people do the box method, where you write the terms on the top and you make a 4x4 Punnett square looking box. I prefer FOIL because I can color code it and it makes it a little easier. So here's what we're going to do. We're going to multiply. We're going to multiply by using the first term. So 3 times 2 is 6. We're going to multiply the outside terms of the sandwich. If this is a 4-term sandwich, we're going to go with these outside terms. 3 times positive 3i would be positive 9i. We're going to go with the inside terms, or spelling the word FOIL. First terms, outside terms, inside terms, last terms. Negative 4i and 2 is negative 8i. And then the last terms, knowing that we got to be really careful with our signs, our pluses and our minuses. Hang on, let me change colors. We go orange. We're going to multiply our last terms. So negative 4 times 3 is negative 12. I times I. If you multiply anything by itself, you get I squared. And that I squared is going to do something really cool, which we have not defined. Oh, we're about to define right now. Remember, I squared is negative 1. Why is that? Well, if we take our first term, all right, we just FOILed. I'm going to go up here and do a little expounding on this definition because we just got an I squared and we've never seen it before. So here's that original definition of I. Well, what happens if we square both sides? If you square both sides, squaring gets rid of that square root, right? And we're left with negative 1. And if you square the right side, you get I squared. And we've got a new definition of, well, here's I squared. I squared is negative 1. And what that's going to do is let us simplify this FOIL even more. So we've still got our 6. We can combine the like terms in the middle to get a positive I, because 9 minus 8, 1. And then we're going to leave this 12 alone, but I'm going to change that I squared. And there's a remember right above. If you look right above, it says, remember, I squared is negative 1. It's an important fact to have in our toolkit. And then we're going to say negative 1. And now we've got two constants that we can combine. So we've got ourselves 6 plus I plus 12, because a negative and a negative make a positive. And we end up with something like 18 plus I, another mixed complex number. Cool? So we got practice multiplying binomials, which we do through the FOIL method or the box method. And then we've got a little bit of combining like terms and applying this new definition of what I is. Awesome. We are going to divide, and then we're going to wrap it up and be done. So dividing, it requires knowing the special term, the complex conjugate. The complex conjugate is changing one sign, S-I-G-N, changing one sign in your term. So look at this example, and that's the best definition. You can read through the definition, but the best example is look at what they've done. They've changed the sign of the I term. The I, even if it were in the front or the back, doesn't matter. You find the I term, whatever term has I, and you change it from positive to negative or negative to positive. And so real quick, let's take 5 seconds. Where's the I term? We're going to change the sign to find the complex conjugate. I'm going to go ahead and define this. We'll say that this is, I don't know, x equals negative 3 plus 4i. And on the homeworks, and a lot of times you'll see the complex conjugate written with a bar on the top. So x bar, the complex conjugate, is equal to negative 3. Don't change that term. we're going to just change that to a minus sign, minus 4i. That's all we've done, and that's the complex conjugate. Now, why would we need this complex conjugate? It's because it's going to let some really cool things happen when we divide. So adding and subtracting, pretty normal. Combining like terms. Multiplying, a little different. You got to FOIL, but still combine the like terms. Dividing, we've got a whole different method because division's tough. We don't have this long division or synthetic division yet. So when we divide complex numbers, we're going to utilize this complex conjugate and turn it into a multiplication problem. So here we go. We are going to look at dividing 2 plus 5i by 4 minus I. Here's what we're going to do. We are going to divide the bottom by multiplying by the complex conjugate. And you say, well, are you just allowed to willy-nilly multiply something by something else? No. There's only one number that we're allowed to do that with. We are allowed to multiply by 1. And if we write 1 in a really cool way, which is multiplying the top and the bottom by the same term, all we're going to end up with is the exact same term because multiplying by 1 yields itself. It's the identity under multiplication. So here we go. We'll multiply across the top, multiply across the bottom, and see some cool stuff happen as we cancel out. So we're going to FOIL the top. I'm going to do this a little faster, slow it down, try it yourself. You got 2 FOILs here to really practice. So really you'll get all the practice you need adding and multiplying if you just practice dividing terms. So we're going to FOIL the top, and we're going to go 8 outside, 2i inside, 20i last is going to be 5i squared. And I'll reduce it in a little bit. All right, next we're going to do the same thing. We're going to go 16 first, outside, positive, this is cool, positive 4i, inside, negative 4i. That's a nice little thing that's going to happen. And if it doesn't happen, go back and look at your complex conjugate and make sure you pick the right one, because that should happen every time when you're dividing and choosing your own complex conjugate. And then the last term is going to be negative I squared, and now we can do our simplifications. So I've got 8 plus 22i. I combine the middle terms, plus 5 times negative 1. Remember, don't forget, I squared equals negative 1. This is going to happen all the time. I squared equals negative 1 there too. All right, now the bottom, we've got 16. Those 2 middle terms are going to go away because 4i minus 4i is 0, minus negative 1. Now we can reduce it one more time, combining the like terms. We've got 8 minus 5 on the top, so we've got 3 plus 22i. And we've got 16 minus a negative 1, which is a 17. Those numbers don't reduce. 17's prime, 3's prime. 22 doesn't work with them. They're all relatively prime. So we'll call it a day with that division. All right, there's one more really cool thing about I that we want to point out. Just because it's really cool and it happens a lot and it helps you solve problems a little faster. And that's what happens if you just keep multiplying I by itself. So I one time, or I to the first power, is the square root of negative 1. We defined that earlier. And then we expanded that definition, said, well, if we square both sides, we actually end up with negative 1. Totally cool. But now what happens if we do it 3 times? If we do it 3 times, wouldn't we just be multiplying I2 times I1? And so we got those 2 definitions above, and we can see that's just going to be the negative root of negative 1. Doesn't seem too cool yet, kind of goes with what we're doing, but watch what happens next. Wouldn't I4 just be multiplying that again by I1? So you can break it up one of 2 ways. This way I think is easier to see. We're going to multiply it by I2, because if you add those exponents, properties of exponents, you get that 4. And now what is I2 up above? That's just negative 1 times negative 1, and you get 1. Now that's a nice weird number, because what's going to happen next is we're going to have that 1 in there, and it's going to make our answer pretty similar to before. So hop over up to the next top. I know these are a little different. I to the 5th power, isn't that just I4 times I1? Well, we have I4 and we have I1. I4 is really easy because it's just 1, and I1 is going to be the root of negative 1, and isn't that just the root of negative 1 back where we started? And so this is why up above the definition says these are cyclic powers. They cycle through all of the numbers you could possibly think of for an exponent, and you're just going to keep ending up with the same numbers. Ooh, I want to point out here, we have a definition for that. So wouldn't this just be negative I? Just another way to look at the same thing. And then we end up with 1 again. And this can be said for any number of an exponent, which is this down below the generic form of these powers, where if you add 1 to any number, so let's say where n is a real number, n is an integer. So n needs to be an integer for this to work. We're not working with decimal exponents. And if n's an integer, so like n 0, then that first power is 1, right? And so if n is 0, let's just pretend, then that first one is a 1, and we know that that is the square root of negative 1. But what if n's 1? If n's 1, we end up with I5, right? And we just defined I5 above. It's the exact same thing. It's the square root of negative 1. And what if n's 2? Then we end up with 9. And it's the same thing. It's just the square root of negative 1. So this cyclical power is going to keep happening. So we'll end up with negative 1. If we add 2 to that, we're going to end up with negative 1. If we add 3 to that, we're going to end up with negative I. And if we add 4 to it, or we add 0 to it because it's in the power of 4, the cycle repeats every 4, we are going to end up with 1. So that's I to the 0, which is really cool because anything to the 0 is 1. That's I to the 4, which we just defined earlier, and you could keep going. And so with that, they sometimes ask you to evaluate a really big number, like 2,000 or something. And there's a couple ways to do it. If you're taking a test and you want to be super careful, one cool way to do it is you could divide 18 by 4 and look for the remainder. So you get a 4 on the top, 16 with a 2 remainder, right? And you could use that remainder to see how many left over do I have, and that would be that remainder. Or if you want to be even carefuler, just because you're taking a test and you don't want to mess up and you want to do a good job, you could take that 18 and just go 18, let's chunk it down by 4. Let's go 4 down. So this I to the 18 is actually going to be the exact same thing as I to the 14, which is exactly the same thing as I to the 10, which is exactly the same thing as I to the 6, I to the 2, and we just said that's negative 1. And there's that remainder showing up in the exponent. So just to look at this in 2 different ways. All right. So that's kind of the bare bones of what complex numbers and dividing or square rooting this negative number turn into, and how we can pull out this I, treat it as a constant, even though we know the value, to work with the square roots of negative numbers and complex numbers. Hope to see you next week. Don't forget to work through your homework, read the textbook, read the notes, and try some of these practice problems on your own before attempting the homework and then getting to our first test later on this week. Hope you have a great day, and I'll see you tomorrow.